Okay, I wanted to take a little bit of time and go over these problems and show you exactly what I will be looking for in terms of even work tomorrow. So the first part of your quiz is going to be determining whether the triangles are similar by angle, angle, side, 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 and side, angle, side. So my biggest fear for my online students right now is that your assignments have kind of been multiple choice. So you may not really know why something is one of these things. So I want to walk through this review with you and hopefully help you with that. So for number one, in order to figure out if these are similar by these three different things, you have to kind of take a step back and look at what you're given. So we are given 3 side links on this triangle, 3 side links on this triangle. So we are going to try to use side, side, side. I say try because in order to use side, 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 all of your fractions have to reduce or divide out to be the same thing. So the smallest side on this triangle is 37.4, and that's going to correspond to the smallest side on this triangle, which is 17. The middle side on this triangle is 44, which is going to correspond to the middle side, which is 20, and then longest over longest. And now we're just going to divide these out, and I need to see this step. So I need to see how these all divide out. So take 37.4 divided by 17, and I get 2.2. 44 divided by 20, I get 2.2. 55 divided by 25, I again get 2.2. So because they all divide out to the same thing, these are similar by side, side, side. That's it. Number 2, now this one does not really require any work. So we have an angle in common, and then they also have vertical angles. So now each triangle has 2 angles that match up to the other 2 angles in the other triangle. So these ones are similar by angle, angle. So angle, angle really doesn't require work if it just has markings. Number 3, so this is a little bit different of a situation going on here. So we have 2 triangles. We have this XWT, this triangle right here, which we're given 2 sides only. And then we also have, I'm looking for a yellow highlighter. That's not it. We also have this triangle XYZ that also technically has 2 side links. So if I take a look at my 2 triangles, I have 2 sides, 2 sides. Up here, if I had, the only one that uses 2 sides is side, angle, side. But if you look at these 2 triangles, they share that X. So we are going to try for side, angle, side because they do have the angle that they share. So in order to use side, angle, side, whenever you're using sides, you have to match up your sides with each other. So between the 20, so this blue triangle has a side length of 28 and a side length of 30. My yellow triangle from X all the way to Y is 35 because I take 28 plus 7. And then from X to Z is 38. So whenever you're using sides, you have to set up a proportion and check and see if they reduce down to the same thing. So this side 28 is the shortest between my 2 here. That's going to correspond to 35, which is the shortest on my yellow triangle. Then I go back to my blue triangle. This side is 30, and that's going to correspond to the longest side on my yellow triangle, which is 38. And again, I'm using side, angle, side because they both of my triangles here, my blue and my yellow, they have that angle X in common. So in order to actually be able to use side, angle, side though, these have to reduce down to the same thing. So this gives me 0.8, 30 divided by 38 gives me 0.789. So these 2 numbers, even though if this could round up, they are not the same. So this is going to be not similar. It would be similar by side, angle, side if these reduce down to the same thing, but they don't. All right, number 4, we don't have any side links on the outside, so we are going to try for angle, angle. In order to use angle, angle though, we do have to have 2 angles that are exactly the same per triangle. So we have 1 pair right here. The 106 is not the same thing as 45, but we can find that 3rd triangle in this or the third angle in that triangle. Because if you take 29 plus 106, you get 135. But then if we subtract that 135 from 180, I find this missing angle to be 45. And since both of these are 45, these triangles are similar by angle. Number 5, we have vertical angles going on here, and we have two sides with the angle in between, two sides, angle in between. So we are going to try to use side angle side. So in order to use side angle side though, whenever you use sides, you have to set up a fraction of the sides that correspond and make sure they reduce to the same thing. So between the 48 and the 56, 48 is the smallest. That's going to correspond to the smallest side over here, which is 60. And then 56 is going to correspond to the 70. Now divide those out. 48 divided by 60 is 0.8. 56 divided by 70 is 0.8. So because they're the same, we are going to use side angle side because we have two sides and an angle. I have to see this work. I have to see your fractions. Number 6, we have 3 side lengths given per triangle. So again, we're going to try for, like we did in number 1, we're going to try for side, side, side. And again, you have to set up your fractions and divide them out. So I always go smallest to largest. So 64 is the smallest on this triangle. On this triangle, 36 is the smallest. Then the middle is 80, and then that corresponds to 45. And 96 will correspond to 54. Divide them out. 64 divided by 36, I get 1.7 repeating. 80 divided by 45, so far so good, 1.7 repeating. 96 divided by 54, perfect. So because they all reduce to the same thing, these are similar by side, side, side. But again, you can't just put side, side, side. You have to show this. This without this gets this answer marked wrong, just so you know. Number 8, we have the same type of situation as in number 3. We have this triangle, LKM, that has a side lengths of 21 and 10. And then we also have a triangle, LJN, that has side lengths of 21. Oh, actually, I don't know what that side length is. I lied. That has 10, and I don't know that side length. I have to find it. But LJ has a side length of 21, and then this side length would be 14 of my big triangle here. So they do still, these two triangles, because you have a triangle within a triangle, they share L. So I'm going to try for side angle side. So there's my angle. So in order to, whenever you use the sides, you do have to set up your fractions. So I'm going to do 10 over the entire length of the other side of the triangle, 14. And then this length right here, if the entire length is 21 and this is 6, 21 minus 6 is 15. So this has a length of 15. So this length of this triangle is going to correspond to the entire length of the side of the other triangle. So then I divide them out. 10 divided by 14 is 0.714, yada, yada, yada. 15 divided by 21, it's exactly the same thing. So now because they are the same, you can say that these are similar by side angle side. But again, you can't say side angle side without showing the work as well. Some of you have noticed that we are getting pickier on your work. So please make sure that you are showing your work for your quiz and being careful. On the back here, or on the other page, I did decide to only do a couple of these. Overall, people have been doing really well. Whenever you have to solve for X, you set up a proportion, cross multiply, solve. So for number 4, you can't mess these up if you set them up correctly. So for number 4, I'm going to do 2 over 6 equals X over 9. Cross multiply, 6 times X is 6X, 2 times 9 is 18, divide by 6, 18 divided by 6, you get X to equal 3. Like I said, you really can't mess them up. I'm going to do this one's work up here. So for number 5, X over 12 equals X plus 1 over 15. Cross multiply, and I get 15x equals 12x plus 12. Because remember, you have to, oops, sorry, you can't see that. Because you have to multiply the 12 by the 1 and the x. Subtract 12x. 3x equals 12. Divide by 3. X equals 4 for that one. For number 6, 8 over 7 equals 16 over 2x. Cross multiply. 16x equals 16 times 7 is 112. Divide by 16. And for number 6, you get x to equal 7. Number 7, same thing. Do 5 over x equals 3 over 6. Cross multiply. 3 times x is 3x equals 30. Divide by 3. X equals 10. Skip this one. You don't want to even deal with that. Skip this one. Skip this one. Down here. 16 over x equals 12 over 9. Cross multiply, and you get 12x equals 16 times 9 is 144. Divide by 12, and you get x to equal 12. And again, set up a proportion. X minus 4 over 6 equals x over 9. Stay consistent. You can't mess them up, guys. Cross multiply, you get 9x minus 36 equals 6x. Oops. Subtract 9x. Negative 36 equals negative 3x. Divide by negative 3, and you get x equal 12. I need to see all this work. So if you're solving a proportion, you're solving for a side, you will have a decent amount of work. If you are solving, or when you are proving your triangles to be similar, if anytime you use sides, you do need to set up your fractions. I will be available at 6:15 tonight for a Google Meet for those who want it. Just please check back here for the meet code.